Welcome to ES7 Lesson 4. We are going to talk about kites, trapezoids, and isosceles trapezoids today. Remember last class we talked about rhombi, squares, and rectangles. This is the last lesson of Essential Standard 7. So today we're going to do a little bit of what we did at the end of class last time. So we're going to fill in these with always, sometimes, or never. So a square is a rhombus. Well, to be a square, it needs to have 4 congruent sides and 4 right angles. In order to be a rhombus, it just needs 4 congruent sides. So this would be always. A square is always a rhombus. A rhombus is a square. Well, that is sometimes. Sometimes it'll have the right angle, sometimes it will not. A parallelogram is a rectangle. That is also sometimes. And a parallelogram is a square, also sometimes. A kite is a parallelogram. A kite is a shape that we haven't talked about until today. So a kite, if you think about a kite that you may have flown when you were a little kid, looks something like this. This answer is never. What is the value of x? So this is reviewing back into the first learning target. We know that the exterior angles of any polygon add up to be 360 degrees. So I will add those together. So we'd have 5x, 98, and 75 is 173. So then we would subtract 173. Let's see, that is 187. Divide by 5. And we get x is 37.4. So we're going to use the properties of trapezoids here. A kite is a quadrilateral, so it always has 4 sides, with exactly 2 pairs of congruent consecutive sides. Remember, a rectangle has 2 pairs of congruent sides, but these are consecutive sides. Consecutive, remember, goes in order. So that's why they've got this side and this side that lie next to each other, congruent, and then these 2 sides that lie next to each other, also congruent. So that would make kite A, B, C, D. Special properties that we know about a kite. We know that the diagonals of a kite are perpendicular to each other, so they make a right angle. We also know that it bisects one of the diagonals. The other diagonal we can visually see is not bisected. We also see that it has exactly 1 pair of opposite angles congruent. So this angle B is congruent to angle D. But you notice that angle A and angle C are not congruent. So Lucy is framing a kite with wooden dowels. She uses 2 dowels that measure 18 centimeters, 1 dowel that measures 30 centimeters, and 2 dowels that measure 27. So this here is the 30 in the picture. To complete the kite, she needs a dowel to place along KL. So she needs this long support so that way it doesn't just fold in on itself. She has a dowel that's 36 centimeters long. About how much wood will she have left after cutting the last dowel? So we know that it's going to be less than 36 centimeters to make that KL. What I know is that this diagonal is cut in half. So both of these are 15 and 15. I also know that the diagonals of a kite are perpendicular to each other. So now what I'm going to highlight in green is a right triangle. So whenever I have a right triangle and I know 2 sides, I'm going to simply use Pythagorean theorem. So a squared plus 15 squared is equal to 18 squared. So a squared plus 225 equals 324. So we would subtract 225 from that, and we'd be left with 99. So we'd take the square root of 99. So 99 is 3 times 33. 33 is 3 times 11. So I've got a pair of 3's. So A would be 3 times the square root of 11. But this is a word problem, so that probably doesn't make the most sense to us. So I'm actually going to pull up my calculator here, and I'm going to take the square root of 99, and we'll realize it's, the square root of 99 is just under 10. We get 9.95. So equals 9.95. Now that doesn't give me the whole dowel, that just gives me this right angle, or this side of the right triangle. I need to do the same thing for this bottom triangle. So I'm going to highlight that here in blue for you. So now here in blue, I'm going to do the same thing. So a squared plus 15 squared equals 27 squared. Because again, this is another right triangle. So a squared plus, whoops, sorry about that. 15 squared is 225. And 27 squared is 729. So we subtract 225 from that. We get 504. We take the square root. And we're not even going to bother with doing the exact answer because we know that we're looking for a decimal answer. We get 22.45. So now I want to add those together. So 22.45 plus 9.95 is 32.4. So that'll be my total dowel length. So from K to L is 32.4. I had 36, so I'm going to take 36 minus that answer. Leaves me with 3.6 centimeters of wood left. So they tell us again that this is kite ABCD. So I know that these two sides are going to be the same and these two are going to be the same. Angle DAB is 54. So this entire angle here is 54 degrees. We know that the diagonal bisects this angle. So each one of these are going to be 27. And it says the measure of angle CDF is 52. I would also know that this angle here is 52. And of course I know that those intersect at a right angle. Find the measure of angle BCD. So I need to find the measure of this angle here. Well, I've got a couple options. So one of my options, if I look at this triangle here, I have a right triangle, and I know the angle 52 degrees, so then 90 minus 52 is 38 degrees. So I know that this angle would be 38, and likewise this one would be 38. So the measure of angle BCD would be 76 degrees. Now it asks us for the measure of angle ABC. ABC is that angle there. Well, if I look at this as a triangle this way, so I highlighted a big purple triangle there, I know an angle of 27 degrees, and I know an angle of 38 degrees. I'm going to ignore the 52 because I want this entire angle here, so I'm not even going to worry about the 52 there. I'm just going to add those together. Is 65 degrees. Take 180 minus 65 is 115 degrees. So that would be the measure of angle ABC. Next is our next shape is a trapezoid. A trapezoid has exactly one pair of parallel sides. So we know that right away a trapezoid cannot be a parallelogram because parallelograms have two pairs of parallel sides. Each of the parallel sides are called bases. We can draw it standing up on its side if we want to. And these two sides would still be my bases. No matter how it's drawn, the parallel sides are always your bases. The other sides, the non-parallel sides, are called your legs. We know that the base angles of a trapezoid are two consecutive angles whose common side is a base. So angle A and angle D are base angles. Angle B and angle C are base angles. One other thing that we know, remember that with these two lines being parallel and this being a transversal, we know that angle A and angle B would be consecutive interior angles, so they would be supplementary. Same thing with C and D. So they want us to show here that that is a trapezoid. I can visually see that CD and EF are not parallel. So I'm going to be looking to prove that side DE and side CF are parallel. So DE, I can see I'm going up 1 over 3. The slope of CF, I can see that I'm going up 2 and over 6, which simplifies to be 1/3. So we know that DE and CF are definitely parallel. Now I need to show, just to prove that it is, I need to show that the slopes of the other two lines are not the same. So the slope of EF, I'm going down 2 over 2. So that's a slope of -1. And the slope of CD, I'm going up 3 over 1, which is a slope of 3. So since they're not the same, EF is not parallel to CD. So because they have exactly one pair of parallel sides, it is a trapezoid. If the legs, so remember the legs are not the bases, of a trapezoid are congruent, then it's called an isosceles trapezoid. So these are theorems about isosceles trapezoid. A regular trapezoid still exists. It's just when it is an isosceles trapezoid that we have a bunch of special properties. What I know is that the base angles are congruent. So A is congruent to D and B is congruent to C. I also know the converse of that. So I know if it has congruent base angles, so if I know that A is congruent to D, then I know for sure that this has to be isosceles. So these are converses of each other. And then the last one, if it's an isosceles trapezoid, I know that the diagonals are congruent to each other. Note that the diagonals do not bisect each other, because if they did, that would make it a parallelogram, and we know that a trapezoid cannot be a parallelogram. So here they want us to find the measure of angle A. So right away, I see these tick marks, and I see that these lines are parallel, so that makes that an isosceles trapezoid. So I know that these angles would be the same. I also know that B and C have to be supplementary, so that makes this angle 80, and it makes this angle also 80 degrees. Noting that it's still a quadrilateral, so 4 minus 2 times 180 is 360. Those angles still add up to be 360, kind of tying that back in with the first learning target. Here they tell us that KB is 21.9 and MF is 32.7. Sorry, that got a little sloppy there. Find FB. So what we know is, since this is an isosceles trapezoid, because the two sides are the same, I know that the diagonals have to be congruent to each other. So I know that FM is the same length as JK. So that means that BM would have to be a length of 21.9. So I'm just going to take 32.7 minus 21.9. Let's see. We'll do that on the calculator real quick. 32.7 minus 21.9 is 10.8. So on your own, please pause the video and try this problem. Okay, so here's what you should have done. So it told you that JN is 10.6, and it told you that NL was 14.8. So we know that the length of JL would add those two together. So that would be 25.4. And we know that KM and JL are the same. So that's length of KM as well. Here they want to know the value of A that makes it isosceles. So what we need to know is that if it's an isosceles trapezoid, that those base angles need to be congruent. So I need to set A squared plus 27 equal to 2A squared minus 54. I'm going to subtract A squared from both sides. And I'm going to add 54 to both sides. So 27 plus 54 is 81. 2a squared minus 1a squared is 1a squared. We're going to take the square root of that. And we get a is equal to plus or minus 9. Because remember, negative 9 squared is also 81. If I plug positive 9 or negative 9 back in, they both work, so that's why I need both answers. The mid-segment. You remember we did mid-segment with triangles? Mid-segment of a triangle connected the midpoints. Same thing on a trapezoid. So it's connecting the midpoints of your legs. Remember that the mid-segment theorem said that it was half as long as the side that it didn't touch. For a trapezoid, it's a lot the same. It's actually the average of your two sides. So if you know the length of BC and you know the length of AD, it's the average of those two because it's halfway between them. So we simply add the two lengths and divide by 2. So we want to find EF here. So they give us the two base lengths. So I'm simply going to take 8 plus 13.5 and divide that by 2. So 21.5 divided by 2 is 10.75. Try this one on your own. Please pause the video. Okay, welcome back. So if you put a variable x here, you could have said x plus 25 divided by 2 gives us 16.5. So if we solve this algebraically, we'd multiply both sides by 2. So x plus 25 equals 33. Subtract 25, and we get 8. That's great if you did it that way. There is another way. Since these are numbers, we can reason this out. How far is it from 25 to 16.5? Well, 25 minus 16.5 is 8.5. So then if I take 16.5 minus 8.5, I get an answer of 8 as well. So when we deal with numbers, we could work it that way. But if we do an algebraic expression, it's not quite that easy. Please grab this hierarchy from last time. So last time we filled in quadrilaterals. We put parallelograms here. We put rhombus, rectangle, and down below here we put square. So now we're ready to add in our 3 new shapes. We had a kite, we had a trapezoid, and I had an isosceles trapezoid. So whenever we go to fill in, like always, sometimes, or never, is a parallelogram a rectangle? So if you're working your way down a tree, it's sometimes. If you're working your way up the diagram, so is a rectangle a parallelogram? That's always. So up is always, down is sometimes. And if you're going from one tree to another tree, it's never, with one exception. A rhombus is a rectangle sometimes. And that one point in time is when it is a square, because they have something in common down there at the bottom of the tree. So you can go in, this is one piece of homework that you got. Please go in and fill out this with the shapes. On the back side here, I would like you to go through and I would like you to fill in, for each one, I want you to fill in the name. So like here, you'd put trapezoid. And then I want you to give me all the special properties of the sides, give me all the special properties of the angles, and all the special properties of the diagonals. Do that for each of these shapes. Then your last piece of homework is to come in and fill out this chart. So I will do the parallelogram part for you. So for a parallelogram, are the opposite sides parallel? Yes, it is. So I'm going to put an X there. Are the opposite sides congruent? Yes. Are the opposite angles congruent? Yes. Are consecutive angles supplementary? Yes. Are all angles congruent? No. Are all sides congruent? No. Do the diagonals bisect each other? Yes. Yes, they do. Are the diagonals congruent? Not for a parallelogram. Are the diagonals perpendicular? No. Do the diagonals bisect opposite angles? No. Is there exactly one set of parallel lines? No. Are the base angles congruent? A parallelogram doesn't have base angles, so no. And is there exactly one pair of opposite angles congruent? No. So go through the other shapes and mark down the things that are true for that shape. When you have finished that, you are done for the day. Thank you.